Okay, grade 10. How are you? Are you fine? Class 10 students, are you fine or not? So, I hope everybody is doing well, right? Now, what you have to do, you have to make note. Take out your pen, paper, and what is discussed. That should be done. That should be written in your copy. And nowadays, what are you doing? We are doing our online class in question answer pattern. So I will say you the question and you have to write the question, and later on I will say the answer and you have to write answer. So question answer system. Let me share the screen what we are going to discuss today. So just check it here. What is being shared now? Document I have written here. Now you can mute your audio so that it will not disturb others. Okay, class 10. Class 10. Now be ready here. What is given? I think nowadays these nets are being quite slow. In every sector it is like that. Okay students, what we have discussed, it was already shared the video. If you have got any doubt you can ask me, otherwise go through the video. Students, in today's class, at first we are going to discuss about soft sales, their types, and presence of soft sales in different cells, main cells. And afterwards we will be discussing about electronic configuration and its symbolic notation. Okay, and next one, Aufbau principle. All right, Aufbau principle will be discussed, and afterwards electronic configuration of first 20 elements. It is very important. And then we have to write next thing. What is that? Blocks of modern periodic table. S block, P block, differences between them, D block, F block, and we can write difference between them also. So those things will be discussed in today's class. So students, first of all, let me tell the question. I will make you to write the answer and you are going to memorize it, and after the end of this question answer session I will ask you to write and say what you have written in today's class. Okay, first question. Define soft sales. Define soft sales. Give their examples. Okay, define soft sales and give their examples. Okay, now students, you write down the definition. The region around the nucleus. The region around the nucleus where the probability of finding the electrons maximum, the probability of the region around the nucleus where the probability of finding electrons maximum is called soft cell. So soft cell lies inside the cell. Soft cell lies inside the cell. So cell is bigger area or region, and soft cell is smaller area or smaller region. So this thing you have to keep in mind. Now example of soft cells. There are 4 soft cells. They are S, P, D and F. S, P, D, and F. These are subcells. Students, K, L, M, subcell S, P, D, F. Okay, S, P, D, F are S, P, D, and F. Okay, did you write? Now write down next question. What is the question? Write the types of cells present in K, L, M, and N cell. Write the type of subcells present in K, L, M, and N cell. Okay, you might have written the question. Now answer. The types of subcells present in K, L, M, and N cell is given below. Types of subcells present in K, L, M, and N is given below. So you write down K cell arrow S, L cell arrow S and P, K cell arrow S, then L cell arrow S and P, M cell arrow S, P, D, and N cell arrow S, P, D, F, in that way. K S only, L S and P, M S, P, D, and N S, P, D, F. In that way we have to write down. Okay students, now next question. Write the maximum electrons that can be fitted in each subcell. Write the number of maximum electrons that can be fitted in each subcell. You can write down this question also. Now answer. Answer is, you just write down the number of maximum electrons that can be fitted in each subcell is given below. S subcell arrow 2 electrons, P subcell arrow 6 electrons, D subcell arrow 10 electrons, F subcell arrow 14 electrons. In that way you can write S2, P6, D 10, F 14 electrons. Okay. So students, now let's go to next question. What does the question say? Alright, question is here. Define electronic configuration. Define electronic configuration. Students, now it's the time to write the answer. The systematic representation for the distribution of elements in different energy levels of an atom is called electronic configuration. The systematic representation for the distribution of electrons in different energy levels of an atom is called electronic configuration. That's the definition. Okay students, let's take one example. Example of hydrogen atom is given. Hydrogen, you know, the atomic number of hydrogen is 1. So earlier we mentioned that K cell has got 1 subcell, L has got 2, M has got 3, N has got 4, N has got 5. In that is given. So in K cell there is one subcell S. L cell there are two S and two P. Yes, M cell, yeah, okay. No, K cell 1, L cell 2S and 2P, M cell 3S, 3P, 3D, N cell 4S, 4P, 4D, 4F. First one is K. No, first K, then L, M, N. And this is O. This is mistake. Oh, that is O. Okay, not two times. Okay, K, L, M, N, O, P. It goes like that. Alright, so K cell has got only one subcell, that is 1s. So hydrogen atomic number is 1. So what is written here? Check it here. 1s power 1, isn't it? 1 means first cell. S is subcell. First cell has one subcell. This 1 you can see at the top as power, so that is the number of electron. So 1s1, this is electronic configuration of hydrogen. Okay students, if you have to write the electronic configuration of helium, then what do? See here, helium means atomic number 2. So we write here He, helium. It has only one cell, 1s or first energy level, and it contains 2 electrons. So we write here 1e1, not here He. What do we write here? 1s, 1s2. Electronic configuration of helium is 1s2. Okay, so later on we are discussing electronic configuration of different elements. Electronic configuration means simply the distribution of electrons in different energy levels. Now question arises here, what are energy levels? So energy levels are those areas or regions where electrons are found in maximum number. Like I say K, L, M, N, O, P. Among them, so K is first energy level, L second, M third, N fourth, etc. Okay, my dear students, now you just check here. You can see something written over here, NXE. N means number of cell, X is cell, subcell, and this E, that is number of electrons present in that particular subcell. So it is just like coefficient, base, and index. Coefficient, base, and index. Now students, next question, will you write? Question is, state Aufbau principle. State Aufbau principle. So here is given the heading. So the heading is given here. Let me circle it so that you can write the spelling correctly. Aufbau principle states that electrons occupy the subcells of minimum. Aufbau principle states that electrons occupy the subcells of minimum energy first, and then they occupy the subcells of maximum energy. Let me repeat again. Our above principle states that electrons occupy the subcells of minimum energy level first, and then they occupy the subcells of maximum energy. Here we have to keep in mind all the subcells are not found in same energy level. They are in different energy levels. So for that, one German scientist named Wolfgang Pauli, what is the name? Wolfgang Pauli, he gave idea how are the electrons located in subcells. We have mentioned that there are four types of subcells. They are S, P, D, F, and they are present in cells. Cells are K, L, M, N, O, P. But next thing you have to keep in mind, K cell has only one orbital, that is 1s we write here because it is first energy level. L cell has got two, they are 2s and 2p. M cell has three, they are 3s, 3p, 3d. N cell has got four, 4s, 4p, 4d, 4f. And O cell has got 5. No, O cell has got also 4 subcells, 5s, 5p, 5d, 5f. Okay, students. Here, which are the energy levels? 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p. These are energy levels. But electrons are not filled in all at once. For filling the electrons, German scientist he suggested energy will be filled first in lower energy level and then higher energy level. He gave one technique. How are the electrons filled in the subcell? So for that, he showed clearly first electron is filled in 1s. When 1s is filled, then it goes in 2s. When 2s is filled, it goes in 2p. After 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, in that way. First, lower energy level is filled and then higher energy level. So who gave this idea? German scientist Wolfgang Pauli. My dear students, now write down next question. Write the energy levels of an atom. Write the energy levels of an atom. So for that you can write down the energy levels of an atom are right in this way: 1s, 2s, 3s, 4s, after 3s 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, in that way write up to 7p. 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4p, 5d, 6p, 7s, 5f, 6d, 7p. Students, there must be comma in between the subcells or energy levels. Alright students, let me go to next screenshot. What is here? What does it say? Here students, it's given electronic configuration of some elements. So what do? We will write electronic configuration of first 20 elements. Will you write the heading? Electronic configuration of first 20 elements. For that, you have to write the elements first. I will guide you how to do. Look at the screen. It is given here. First write down hydrogen, arrow, helium, arrow, then afterwards lithium, arrow, beryllium, arrow, boron, carbon, nitrogen, oxygen, fluorine, neon. In that way it goes. Okay. So let me complete these all. Hydrogen, its atomic number is 1. Hydrogen atomic number 1, helium 2, lithium 3, beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8, neon 9. Okay students, 1 electron means 1s1. This is the electronic configuration of hydrogen. Helium 1s, this is 1s1, okay, 1s2. Lithium means there are 3 electrons. 3 electrons means 1s2. Can you write 1s3? No, because the capacity of S is to hold only 2 electrons. After 1s, what is the energy level? 2s1. See, 2 plus 1, 3. Beryllium 1s2, 2s2, 4. Boron 1s2, 2s2 and 2p1. S subshell can, 2p1. 1s2, 2s2, 2p1. Okay, that is boron. Carbon. Boron 1s2, 2s2, 2p1. Yes. Now carbon. For carbon, write down 1s2, 2s2, 2p2. Nitrogen 1s2, 2s2, 2p3. Because in p subshell we can keep maximum 6 electrons. Oxygen 1s2, 2s2, 2p4. At last 2p4. And fluorine 1s2, 2s2, 2p5. 2p5. Okay students. Then neon, write down neon 1s2, 2s2, 1s2, 2s2, 2p6. Why 2p6? Because it contains 6 electrons. If you add the index of each subshell, then you will get 10. 10 means 10 electrons are present over there. Okay. So first 20 elements you have written with electronic configuration. Now students, what are you going to do? Remaining 10 will write. Number 11, sodium. Write down 11. Sodium. 12, magnesium. 13, silicon. 14, 13 aluminium. It's okay. 11 sodium, 12 magnesium, 13 aluminium, 14 silicon, 15 phosphorus, 16 sulfur, 17 chlorine, 18 argon, 19 potassium, 20 calcium. I hope you have written these all. Now I am going to guide you the electronic configuration of sodium to calcium. Sodium, what can it show? 1s2, 2s2, 2p6 3s1. I've already underlined it. Magnesium 1s2 2s2 2p6 3s2. Aluminium 1s2 2s2 2p6 3s2 3p1. Silicon 1s2 2s2 2p6 3s2 3p2. Phosphorus 1s2 2s2 2p6 3s2 3p3. Students, how are we writing this? This we are writing according to electronic configuration. How are the electrons distributed? Sulfur, atomic number 16, means first 1s2, then 2s2, 2p6, 3s2, 3p4. If you add these powers, 4 plus 2, 6, 12, 14, 16. Chlorine, 1s2, 2s2, 2p6, 3s2, 3p5. Argon, 1s2, 2s2, 2p6, 3s2, 3p6. Potassium, 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. And calcium, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Dear students, you have to keep one thing in mind. These soft cells are always found in order. Means first 1s, then 2s, 2p, 3s, 3p, 4s. Up to that you have to remember. Once again, 1s, 2s, 2p, 3s, 3p, 4s. That is order up to first 20 elements. Second thing, what is that? How many maximum number of electrons can be kept in SPDF? In S maximum 2, P maximum 6, D maximum 10, and F maximum 14. But for first 20 elements, if you know S and P, that is enough for you. Others are also given here. Just remember first 20 elements, electronic configuration. So let me inquire to the students what they have done. Shreya, you tell me what did you write? Shreya, make your video on and unmute your audio. Where is Shreya? Shreya being passive. Hey Shreya, you have to be active. Also your turn. Also you can show your video and unmute your audio and tell me what did you write till now. Come on. Okay. What did you write till now? Question and answer both. Okay, come on.
The region around the nuclear where the probability of electrons is called the subcell. Write the types of subcells. The types of cells are K, L, M, and O.
No. Soft cells are SPDF. Also, correct that. K, L, M, and O, they are cells. And SPDF, they are subcells. Okay, next. Yeah.
Write the maximum electron is in a subcell.
Okay.
S, 2, P, B, E, and F, 14.
Okay.
Define electronic configuration, the systematic repetition of the negative energy level of an atom electronic configuration.
Okay, good. Now it's Shreya's turn. Shreya, okay, Ashok, thank you very much. Now Shreya, your turn. Shreya, unmute your audio and then show your video and read what you have written. Shreya, what are you doing? And one thing, let me remind those students who do not take part in this activity, they will be discarded. Eh? You have to take part actively. Vivek sir, Vivek sir, okay, please.
State
Aufbau principle.
of Ohm's principle.
Yeah.
Of principle state that electron the subshell of the maximum energy first and then they occupies the subshell of maximum energy.
All right. Finish this much only.
The reactor energy of the atom. The energy of the atom are 1s 2
Energy levels. Energy levels. Okay.
yes sir.
Yeah, they are energy levels. Okay. You continue. Continue reading.
4s 3d copy 5s 4d 6s 4f 5d 7s 8f 6d 10d.
Okay. Now, Ojas, your turn. Ojas.
Yes sir.
Okay, come on. What you have written afterwards?
Electronic configuration of phosphate elements.
Okay. Okay.
Hydrogen 1s1, helium 1s2, lithium 1s2, 2s1, beryllium 1s2, 2s2, 2p1, boron 1s2, 2s2, 2p2,
Boron 2p2 or 2p1? No, boron 1s2, 2s2, 2p1. Okay.
sir,
Boron is 1s2, 2s2, 2p1.
2p1,
2p1. Okay. Okay. Continue.
2s2, 2p2,
Yeah. Carbon is 2p2.
carbon 1s2, 2s2, 2p2,
Right.
nitrogen 1s2, 2s2, 2p3,
Right.
oxygen 1s2, 2s2, 2p4,
Right.
fluorine 1s2, 2s2, 2p5,
Good.
neon 1s2, 2s2, 2p6,
Good. Okay. Sujal, your turn. Now, Sujal, your turn. From 11. From atomic number 11. Yeah. From atomic number 11. From sodium.
sodium 1s2, 2s2, 2p6, 3s1, magnesium 1s2, 2s2, 2p6, 3s2, aluminium 1s2, 2s2, 2p6, 3s2, 3p1, silicon 1s2, 2s2, 2p6, 3s2, 3p2, phosphorus 1s2, 2s2, 2p6, 3s2, 3p3, sulfur 1s2, 2s2, 2p6, 3s2, 3p4, chlorine 1s2, 2s2, 2p6, 3s2, 3p5, argon 1s2, 2s2, 2p6, 3s2, 3p6, potassium 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, calcium 1s2, 2s2, 2p6, 3s2, 3p6, 4s2.
That's good. That's good. Very good. So students are writing very effectively. I like it. Now students, we are going to write some other questions. What are there? Let me see. It's given. Okay, dear student, listen. We have studied there are altogether 118 elements known till now, and those elements are kept mainly in 4 blocks. How many blocks?
4 blocks.
They are S block, P block, D block, and F block. S, P, D, F. Okay. So
Yes, sir.
if their valence subshell is S, they are S block. if balance subcell is P, they are P block. Balance subcell is D block. Balance subcell is F block. In that way, they are categorized. Now, question is, what are the different blocks of elements present in modern periodic table? What are the different blocks of elements present in modern periodic table? Now answer. The different blocks of elements present in modern periodic table are S block elements, P block elements, D block elements, F block elements. S block elements, P block elements, D block elements, F block elements. Did you write? Now next question. Next question. Define S block elements. Give any two examples of them. So I think 40 minutes time is already gone. So this is the system. In Zoom, so after 40 minutes, the activity cannot be continued because students, they have to join again if they want to continue. Otherwise, once done, it's finished. Okay? So let's see what does it come here. So they have already sent me friend request. I'm deleting it and sharing things. We were discussing about the question answers from blocks present in periodic table. Okay, students. What was the question that I said you? Define S block elements and give two examples, right? Okay, please write down now. The elements whose valence electron lies in S subcell. The elements whose valence electron lies in S subcell is called S block element. The elements that whose valence electron lies in S subcell. Valence electron lies in S subcell are called, you can write, are called S block elements. Group IA and IIA. Look at here. Group IA and IIA are S block elements. Examples: Na, K, Be, Mg, etc. Next question. Define P blocks elements and give two examples of them. Now answer. The elements whose valence electron lies in P subcell. The elements whose valence electron lies in P subcell are called P block elements. P block elements. Elements of group 3A, 4A, 5A, 6A, 7A and 0. Elements of group 3A, IIIA, IVA, VA, VIA, BIIA are, and group 0 are P block elements. Example: C carbon, N nitrogen, O oxygen, F fluorine. These are the examples of the elements that belong to p block. Their valence electron lies in p orbital. Students, now let's see once. Here we can see electronic configuration. Let's see. The electronic configuration of hydrogen is 1s1. Means which block element is it? Hydrogen, which block element is it? S block. Helium, lithium. Then the next one is here beryllium. Beryllium 1s2, 2s2. I think 2p1 is given. It is mistake. Okay. Boron. Boron. P. So how to know? We have to see at last where there is P block. Where at last there is S block. Where there is P block. Is that clear or not? Now students, I'm just let me show you down one. Here. If you talk about chromium, see here. At last, which subcell is there? D. Means D block. Iron, D block. Copper, D block. Silver, which block? F block. So very easy to identify whether this is S block, P block, D block or F block. Just look at the last outermost orbital. What is given? That is the block of element. Is that clear? Okay students, now last for today is differentiate between S block and P block elements. Differentiate between S block and P block elements. So for that you have to draw a table. Left hand side write down S block elements. Right hand side write down P block elements. And for each table there must be smaller reason to write the symbol number Sn. So generally we write three differences here. First of all, towards S block elements, write down. So S block elements have S subcell as the last orbital. S block elements have F subcell as the last orbital. And for P block, what do you write? P block elements have P subcell as the last orbital. Okay. Now second point, they can have only one or two electrons in the last subcell. So in last subcell of S block elements, there may be one electron or two. That is much only, not more. For P block elements, they can have 1 to 6 electrons in the last subcell. And here, what to write here? Third point, the chemical reactivity of elements increases while going downwards in a group. In case of S block, chemical reactivity increases. In case of P block, the chemical reactivity of elements decreases while going downward in a group. So you can give example of S block elements have 1A and 2A. All the elements of 1A and 2A are S block elements. 3A to 7A means 3A, 4A, 5A, 6A, 7A and group 0. Group 0 belong to P block elements. P block elements. Alright students? Okay, so students, we are continuing the chapter. Which chapter? classification of elements. Today we have completed electronic configuration, subcells, and S block and P block elements. And in tomorrow's class, we will read the remaining portion of the chapter plus discuss the question answers. So please make routine and follow it. So today this much. Have a wonderful time ahead. Thank you.